chapter which is a kind of known to you maybe because of chemistry. Chemistry you learned thermodynamics? Yes, but you will find some differences between chemistry thermodynamics and physics thermodynamics. You will realize it by the end of today's class. And when I was studying thermodynamics, when I was a school student, this chapter gave me some trouble. That is, I was not able to understand it in the first time. I had to read multiple number of times to understand this chapter itself. And that's the reason I say, maybe you may be getting it for the first time, that's upon how you are taking it and how I am teaching. But one thing is for sure, that if you are not concentrating well, and if you are not listening well, or if you are missing this class, it will affect your future class also. Because thermodynamics will be at least taking 2 classes, minimum 2 classes to finish. And today I will be teaching something. In the next class, whatever I teach today will be depending upon today's class. Same like waves and oscillations. So if you are missing today's class, you are going to definitely have problem in the next class, where I will directly go into the processes, adiabatic relations, and second law of thermodynamics. Okay. So let us not waste much time and directly enter into what we are going to do in this chapter. So first, in this chapter I will talk about the very basic things. What is the meaning of system, what is the meaning of surrounding, what is the meaning of boundary, what is the meaning of thermodynamic variables, what is the meaning of equation of state, what is thermal equilibrium, what is thermodynamic equilibrium, what is zeroth law of thermodynamics, what is adiabatic wall, what is isothermal diathermic wall, what is zeroth law I said, then what is the meaning of internal energy of the system, then what is work done on the system, work done by the system. We will learn about the first law of thermodynamics, then we will talk about the processes, different kinds of processes, isochoric, isobaric, adiabatic, isothermal, all the processes we will learning. After learning about the processes, we will talk about the second law of thermodynamics, Kelvin-Planck statement and Clausius statement, and a bit about heat engine, not there in the syllabus much, a bit about introduction about that. Earlier we used to have Carnot engine in syllabus, but I think that is not there in detail now. Whatever is there in syllabus, we will learn that. That's how system, the flow of the syllabus will be. I hope you are clear in this. So today we are going to learn about the basics of it. Let us see how much we are able to cover. I am not saying that we will cover the entire chapter or the part of the chapter. I don't know. Let us see how you cooperate and how much we are able to cover. But one thing I would say today, since it is a kind of chapter where you need to be concentrating well, I request everybody in the class that don't take any notes today much. Little bit notes you can take, but don't focus on taking notes. Focus on understanding the subject. Understand the logic well. Taking notes, either I will give notes to you or you can see the video and copy the notes. That is not a big thing. Note is always available, but this understanding should happen on the one go. See, difference between YouTube class, that is you are seeing the recording and now, is you can ask me questions now. If you have doubt, you can ask me. There you cannot ask question to anybody in the video. Yeah, you can come and later and ask to me, but obviously this class you can interact with me. Are you getting my point? So I want your interaction. I want you to be there in the class physically, mentally, without writing much. Writing part, let us postpone it for you to once again see the video and copy, or I will share the notes with you whatever I am going to write in the PPT, if I am going to write anything. Okay? So please make sure that you are not wasting much time in writing today and understanding whatever I teach properly, because we are towards the end of 11th portions. If you are seeing, now what is remaining is thermodynamics and KTG. KTG is one day topic, very small chapter, 1.5 hours if I take continuously, I hope I can finish it. So now not much days are remaining, probably by Pongal we will be done with syllabus, then we will start revision and test series, all these things. So please understand today's class, understand well. Okay? Let us start the chapter by understanding what is the meaning of the word thermodynamics. It has 2 parts, right? Thermo and dynamics. Without even having any hesitation, I think you can understand what is the meaning of the word thermo, isn't it? What is thermo? What is the meaning of the word thermo here?
Temperature.
Temperature. Can I say temperature or shall I say heat, Pratap?
Heat, sir.
Because heat and temperature are not same, isn't it?
Yes, sir.
Heat and temperature are not same. By now you should know, by learning thermal properties of matter, heat is measured in calories or joules, temperature is measured in degree Celsius, Kelvin, degree Fahrenheit, Reaumur, and all these scales are there. So temperature is measurement of what? What is temperature? measurement of a particular.
Amount of heat.
Exactly. Today we will be able to classify all these things. So thermo, as I said, it is a kind of heat. Ivan, I hope you are there in the class. If you are there, please on your video. Shweta, video should not be off at any point of time. Yes. So thermo means heat, and what dynamics means? Dynamics is again known to you. Dynamics is study of particles in motion with the consideration of the cause of motion. This I teach in the first of kinematics. Whenever I start kinematics, I teach like this only. Mechanics, then mechanics has two parts, kinetics, kinematics, kinematics has two parts, dynamics and statics. So if you remember, you understand that here we are going to learn about what is the meaning of, like what is heat and what are the forces involved in this conversion. So let us define thermodynamics first. As I said to you, thermodynamics, it is a branch of physics which deals with the concepts of heat and temperature. See, main part here is interconversion of heat and other forms of energy. Why are we learning this chapter? Today you will realize that with the help of heat, we can do some work, and while doing some work, we can produce some heat. So heat and work are interrelated. So in lot of mechanical concepts, we are using heat engines. If somebody takes mechanical engineering from this classroom, then a major part of your mechanical engineering of 4 years, you will be learning about thermal effects and thermodynamics only. That much important chapter we are doing today, where the whole syllabus of engineering, mechanical engineering is almost about this thermodynamics only. So if you are planning to take engineering, it's going to be a very important chapter for you. Anyhow, so let me ask a very basic thing from you. I have written here, work and heat are interconvertible. That is, work can be made into heat, heat can be made into work. Generally, if it is cold, what we do? We rub our hands, right? Why rub our hands? You will say to produce heat. Am I right? When you rub your hands, what happens? Heat is produced. Why heat is produced? How heat is produced? By the work that you are doing in rubbing your hand, isn't it? If you rub your hand, heat is produced. Why? Because you did some work, heat is getting produced. So in this case, you understand that work done by moving your palms is getting converted into heat, isn't it? And vice versa. Suppose if I ask you like this, it's an engine. Nowadays we don't have steam engine, but once upon a time we used to have, where a steam is rotating this wheel, and that's how we discovered the steam engine itself. Like go 60 years, 70 years back, all the trains had only steam engine, where we used to have a steam chamber, we'll put coal there, burn, produce steam, and that steam or the heat energy will be used to run the engine of the train, and we will carry the carriages itself, isn't it? So in this example, I am trying to say you, we are converting heat energy into work. In the previous example, what I told you, we are converting work into heat energy, and here I am saying we are converting heat energy into work. That's what I try to say you, that heat and work, they are interconvertible. They are, heat can be made into work, work can be made into heat. Remember this in your mind. This chapter is going to, same thing is going to happen till the end. Okay, so first we will learn about very basic terminologies. I hope by now, with the help of chemistry itself, you would have learned what is system, surrounding and all these things. Once again, I will repeat anyhow. So what is the meaning of system? Generally, system is anything that you are observing. Even you can become a system for me if I am observing you, if I am studying you, if I am analyzing you. So system is anything that is being observed, that is being analyzed, and anything other than system is called as surrounding, isn't it? So for example, if I take Sri Sharan Ram as my system, then everything else except Sharan Ram becomes surrounding for me, and that surrounding and the system is becoming universe for me. Are you getting my point? When I am saying everything other than Sharan, it includes the whole universe. That's how I am going to say about surrounding. So surrounding is anything, everything other than system, and obviously one more thing, there is a boundary. Boundary is a separation between system and surrounding. Now the boundary is a very important thing here. How the boundary is, how much thick it is. Generally what we study in thermodynamics, we assume the boundary to be a thin boundary, so that it does not absorb much heat, or it does not liberate much heat. So we consider the boundary to be always very thin boundary across system. So yeah, one more thing, see here, boundary can be fixed and movable also. Suppose you are making rice in the cooker, then it is a kind of fixed system. But if you have filled gas in a balloon, balloon can start moving above, it is helium gas. In this case, the system itself is moving. So it's not like the boundary itself is moving. So it's not like the boundary has to be always static boundary. Boundary can even be a movable boundary. Moreover, it can also be real or imaginary. That in this case, the boundary is known to you. It is this thing, the vessel. But if you see here, if you are boiling water, if you are making tea, cup of tea, there is evaporation taking place, you cannot define the boundary of it. It will be imaginary boundary. So boundary can be real, boundary can be imaginary, boundary can be fixed, boundary can even be a movable boundary. So remember this, what is the meaning of the word boundary. And I said you that boundary is always considered to have almost negligible thickness, because you want to avoid any heat absorbed by it or any heat lost by the boundary. To avoid this confusion, we always take boundary to have almost negligible, minimum thickness. Then comes universe. I said you, universe is everything, combination of system and surrounding. Boundary, everything combinedly is called as a universe. So if I am studying something, it is system, everything apart from system is surrounding, and the boundary of system is the shape, I should say. See, in physics, what I will say, in physics, if whenever I will say the word system, what should come in your mind is this cylinder. Whenever I use the word system, you should imagine a cylinder with a piston, and cylinder may be filled with some gas if required. This is called as system. Everything other than system is called as surrounding, and system and surrounding together is called as universe. The boundary can be of many types, we will talk about that, adiabatic boundary or a diathermic boundary, we will talk about that. But here in physics, whenever I use the word system, what should come in your mind? Like a piston and a cylinder. For example, the syringe, the injection that the doctor is using, it's something like that you have to imagine. A cylinder, a piston, a movable piston, and inside the piston we may have some gas. Are you getting my point? That is the meaning of system and surrounding in terms of physics thermodynamics. Okay. Now, let us talk about different types of system. So there are basically three types of system: closed system, open system, and isolated system. System, when it is called as closed system, obviously it is when the heat transfer takes place, but mass transfer does not take place. Please mind what I am trying to tell you. This is very important because it will confuse you sometimes. In closed system, transfer of heat allowed, but mass transfer not allowed. For example, you are making rice in a cooker. Before cooker whistles, whatever is there inside the cooker, its mass is conserved, because no exchange is allowed between heat and surrounding and system. So we can say the example of closed system as a pressure cooker before whistling, because when it whistles, it will release some vapor outside. That time its mass may reduce. Yuvan, please mute yourself. Leah Varshini, why is your video off? Yes, coming back. So pressure cooker without whistling is the perfect example of a closed system where we don't have any exchange of mass, but we are allowing heat to transfer. That's why the cooker is getting hot, right? We are allowing the heat to go inside. That is the best example of closed system. Then system can be even open system. Now what is the meaning of open system? Again, having a tea, right? We make a tea, pour into a glass and keep it. What will happen? The heat will be slowly lost in the environment. So in that case, heat transfer takes place and mass transfer also takes place. This kind of system is called as open system, where heat and mass both are getting transferred. Example, tea in a cup. Tea is hot. If you are keeping in the cup, see, I am not saying that significant mass will reduce, but a little bit of milligram mass may reduce, because some of the tea is getting vaporized into the air until it attains the equilibrium, isn't it? Third system, and very special type of system, is isolated system, where neither heat nor mass will be exchanged. Can you give me an example? Thermoflask, isn't it? Where we don't allow any exchange of heat, no mass is getting exchanged. So here we are making a vacuum layer between the system and the surrounding, which does not allow the exchange of heat between system and surrounding. So again I am repeating, there are three kinds of processes, not process systems. One is open system, where mass, heat both gets changed. One is closed system, where heat is getting transferred but mass is getting conserved. Third is isolated system, where mass and heat both are not allowed to exchange. I hope it is clear to you. Very basic thing we are learning. Now coming to state. Now these things are becoming a little more technical now. Up to now I was talking about only system, surrounding, boundary, and I talked about types of system. Now I am talking about state of a system. State means a particular system, what is its pressure, what is its volume, what is its temperature, or in simple words if I say, what are the thermodynamic variables representing a system is called as the state of a system. Are you getting my point? Thermodynamic variables means like this: pressure, volume, temperature. These are called as thermodynamic variables which directly impacts the system. So how can you call a system as what is its pressure, what is its volume, what is its temperature? That defines the state of a system. So how do you define the state? State is defined as the condition of system that described with its properties like pressure, volume, temperature. So for example, I may say P1, V1, T1 as one state, or it may be written as P1, P2, V2, T2, anything. So a particular pressure, a particular volume and a particular temperature defines the state of the system. Is it clear to you? State means what is the pressure, volume, temperature. It can be some other thermodynamic variable also. Whatever thermodynamic variables are defining a system is called as its state. I hope you are clear in this. So next is process. Now once again, process means whenever the state of a system is changing from one equilibrium state to another. For example, initially it was P1, V1, T1, you compressed it. That time its volume may reduce, the pressure may increase, so it became P2, V2, T1 may change T2. So that is called as a new equilibrium state attained. Initially I had a cylinder, I had a piston. It may have a fixed amount of pressure, volume and temperature. I suddenly compress the piston. What it may lead to? It may lead to reduction in volume, increase in pressure, or maybe increase in temperature also. Depends upon whether we did fast or slow, whether the walls are diathermic or adiabatic, something may happen. If there is a change in the thermodynamic properties or thermodynamic variables, then that is known as the process. So in this case, suppose I am having P1, V1, T1, it is changing to P2, V2 and T2, then there is a process taking place. The process can be expansion, it can be contraction, it can be anything. So if I draw one graph for you, can you try to find what is this? Suppose I am drawing. Anything, I am just drawing random thing to you. Think and say what is happening here. What is this process? I will make it simple. Second, let it be third question. First, let me make it like this. As the volume is increasing,
the pressure decreases.
so can I call this as expansion or contraction?
Contraction, sir.
Contraction. So volume is increasing, it is contraction.
No, volume is decreasing here, sir.
Volume
is increasing there,
Huh.
then it's expansion.
It's expansion. How many of you say it is expansion? All of you? Literally all of you? Anybody says compression? You can unmute yourself and speak. Anybody thinks it is compression? Anybody? Kirti, what do you think? It is expansion? Why? Give a try. You may be right or wrong. Secondary. See here, volume is increasing or decreasing? Kirti, tell me. Volume is decreasing. Think and say. Volume is increasing. What about pressure? Increasing or decreasing? So if the volume is increasing and the pressure is decreasing, what can that be? expansion or compression? Anshul, do you have any other observations, or you say it is expansion only? Maybe why you are saying. Yeah, you should be confident in your answer.
Yes, sir, expansion.
So anybody says it is compression? Anybody says it is compression? I say it is compression. Anybody agrees with me?
No, sir.
Okay. Now tell me. It's compression, no? How did you think that the graph is moving from this to this? Let this be point 1, let this be point 2.
Arrow mark, sir. Arrow mark of the graph.
Arrow mark I did not give. Now only I am giving, no?
No, that graph has arrow mark, right, sir?
Oh,
Increasing volume, decreasing.
oh, wait. I'll not do anything. I'll just, I mean, I cannot go back actually in this. Did I draw any arrow mark before this? Mr. Then how, man, you can comment. What I did before was, I have drawn this graph just like this, pressure and volume.
Hmm.
No, where is the arrow in this one?
There's no arrow.
Down. Hey,
No, that one, sir.
then here where is the arrow, man?
Yeah, there's no arrow.
There is no arrow, right? So if there is no arrow, then how can you say that volume is increasing?
Then
Are you
can't
get-
define this graph.
Yes, we can't. Actually, we can't. We cannot say it is a expansion graph. We cannot say it is a compression graph also. It may be expansion, it may be compression, totally depending upon the path. I'll go and talk about the path next only. So if the path is like this, then yes, it is expansion. Because in this path, from 1 to 2, the volume has increased and the pressure has decreased. But if somebody draws the arrow like this, then it means volume has decreased and the pressure has increased. It's compression, isn't it? Don't you agree with me? So always comment on expansion or compression process purely depending upon the arrow sign. So in this case, if, see here, we don't know what is P, what is V, we cannot comment it expansion or compression. The graph that is drawn here by default, if I ask you whether it is compression or expansion, you cannot comment. It is P1, V1, T1, P2, V2, T2. But whether this is V, this is P, they are not mentioned anything. Until they mention, you cannot comment. It may be compression, it may be expansion, it can be anything. So don't judge a graph just by seeing imagining what is P, what is V. Be very careful in understanding which side is pressure, which side is volume, and how is it moving from which point to which point. Okay? Can I proceed further? Okay. So I hope it is clear to you what is the meaning of process. So now, what are the different types of process? Again, I have seen children confusing in this. I'll tell you why they are confusing. So one thing is called as reversible process, another thing is called as irreversible process. What is the meaning of reversible process? Obviously, the process that can be brought back to its original state. That is, if it is having P1, V1, T1, it may go to P2, V2, T2, but it has to return back to P1, V1 and T1. That is, it is defined as the process that can be reversed without leaving any trace on the surroundings. That is important. Many of you are not minding that, because I'll tell you, see, I'll draw a graph. One second. Let me first explain this to you, then I'll come back to that. Yes. So here if you see, P1, V1, T1 has become P2, V2, T2, and once again from P2, V2, T2 it has become P1, V1, T1. This can be called as a reversible process, where the system has attained its initial values of pressure, volume and temperature. Okay, example, I have made example also for you. See here. So the pressure is increasing, the volume is reducing, and once again the pressure is reducing, the volume is increasing. Are you feeling that? So the path from volume 1 to volume 2, from pressure 1 to pressure 2, it is taking the same path while moving. Remember that, because when I am going to talk, see, backward and forward paths are the same, because next what I am going to draw, it will also look reversible to you. See this process, see. Does it look reversible to you? Because the gas started from P1, it came to P2, it came to P3, it came to P4, and finally it came back to P1. you may think that it is reversible process only, because from P1 it has reached back to P1 again. But what I am calling this process as? Irreversible. Why? Because the path is different. Backward and forward paths are not same. Here where children will get confused. They will think this is a reversible process only. No, it is cyclic. I will talk about that. Cyclic is different from reversible and irreversible. Many children think that reversible process must be cyclic. Not like that. Irreversible process also can be cyclic process, like here. So what is the main difference between reversible and non-reversible is, reversible process, the path will remain same, but irreversible process, the path will be different. Are you getting my point? So let me go back. Once again I will talk about this. I hope you are understanding this. So in the case of a reversible process, if you see, the volume has actually decreased, the pressure has increased, but once again the volume has become old and the pressure has become old, but the path that it is following is same. It's not like different path it is following, isn't it? So in which path it came forward, in the same path it goes backward. But now you see in the irreversible process, if this is the path, the path is different while going back to the one. It would have attained the same state, but the path it took to come back to the same state is not same. Shweta, you can off the camera if you want. I hope you are understanding this. 1 to 2 and 2 to 1. If it is not in the same path, then it can be considered to be a irreversible process. So reversible process is the one in which the forward backward path are same. Are you getting my point? I hope. Fine. So now let us talk about path. So path means what? It is the locus of all the intermediate equilibrium states of the system during a process. So for example, if I have a system like this, P1, V1, T1, P2 to T2, then, or I have a third point also, then this is a path of system, again a path of system. If 3 once again comes back to 1, it becomes a irreversible path, but a cyclic path. Are you getting my cyclic? Because from where it is starting, the same point it is ending. See, when I defined reversible process to you, I did not say that if the starting and the ending point are same, it is reversible. I not said like that. I just told that what is the initial state of the system, the same state can be achieved by following the same path. Only then the system is called as reversible system. If the final process and the initial process are same, but the path taken for that is different, then the process can be irreversible process. I hope you are getting my point. So a path is defined as the locus of all the intermediate equilibrium states. Coming back, cycle, I told you. Cycle means, a cycle is a collection of process whose initial and final states are the same. Like whatever I have drawn till now is actually cyclic only. I have not drawn any uncyclic process, non-cyclic process. Are you feeling that? When the gas has gone from P to V and gone back, cyclic only. When I have drawn like this, like this, like this, like this, cyclic only. Even the previous graph is cyclic only. If the starting point and the ending point are same, then the process becomes cyclic. Are you getting my point? So in this case, if you see, there is a path P1, V1, T1, and the second path P2, V2, T2, and third, in this case 1 to 2, 2 to 3, and 3 to 1. This process can be called as a cyclic process, because the process has once again reached back to 1. Started with 1, went to 2, went to 3, went to once again back to 1. This kind of process is called as what process? Cyclic process, because there is a cycle from 1 to 2 to 3 to once again 1. I hope you are understanding whatever I am trying to tell you. Okay. Now comes very important part. Now, if you don't understand this, the whole thermodynamics will become miserable for you. What is the meaning of state function and what is the meaning of path function? Even in competitive examination, these terms will be frequently coming, and you can understand these terms only if you are clear in the concepts of state function and path function. Kirti, you are there in the class, right? Not doing anything else, no? I hope. Okay, coming back. So state function. So if you see the definition of state function, it is defined as The function which depends only upon the end states of a system are known as state function. You remember in chapter work, energy and power, I have talked about something called as conservative and non-conservative fields. Something if you remember, conservative field, non-conservative field. I told you gravitation is a conservative field, friction is a non-conservative field. You remember? Something like that you can, once again recall here. Anyhow, what is the meaning of state function? If the function depends only upon the end states of a system, that is, what is the end? It depends only on that. It is independent of the path. It is independent of the path. This kind of system is known as, function is known as state function. Energy is a state function, remember that. Whether a process is shifting from in the path, this path, or B path, or C path, energy is independent of the path. So energy is what? Energy is a state function, because state function is depending only upon the end result, end state. It does not depend upon the path that you are taking. But whereas if I talk about the path function, so if here state function, then xa is equal to xb is equal to xc. That is, whether the process is moving from 1 to 2 in this path, blue line, or the black line, or the red line, if does not matter, energy remains same. Suppose the process has moved from 1 to 2 in the A path, or in the B path, or in the C path. Energy here are same. It means, not same actually, energy here was even, energy here is E2. Whether you are moving in this path, or this path, or this path, the energy is same. That is, E2 is not changing. It is not like if it is coming like this, E2 will become different. Then the process, that the function is called as a state function. Example of state function, energy. But in the case, I will say you another example, where if I am moving from one state to another state in this path A, second person is moving in this path, second person means second, equation is moving in second path B, or third path C, they are different. That is, work done in this path and work done in this path and work done in this path are different, or heat in this path, heat in this path, or heat in this path are different. Then they are called as path function. As the name is saying, that function which depends upon the path. If path is different, function will give a different result to you. It does not depend upon the end result, it depends upon the path. That kind of function is called as path function. Example, work and heat. So if in this case, the path function of A, path function of B, path function of C are not same. Temperature will be what? Why? If you come in this and this, will the temperature be different? Definitely will be different. Because heat is a path function, temperature automatically becomes a path function. Are you getting? What is temperature? Measurement of heat only. How much it is there in terms of temperature, that is the temperature. Are you getting my point? Coming back. So let us now talk about temperature and zeroth law. Up to here things are clear. State function, example, energy. Path function, example, heat and work done. As of now, remember that. Okay. So I hope you are clear with reversible process, non-reversible process, everything.
Slightly confused, sir.
In what?
I don't get the difference between work and energy right now.
Work and? Yes,
Energy.
I understand what is the problem, because work is also joule, energy is also joule.
Yeah.
So how that differ? Even we have taken heat, right? Heat is also joule only, no man?
Yeah, heat and joule, yeah. Calorie
Yeah.
or joule, yeah.
Yes, so you may feel like work, heat, energy, all are sounding same to me, but why they are saying something as state function, something as path function, isn't it? That's a doubt, am I right? You will understand
Yeah,
now.
sir.
In thermodynamics, we deal work differently, heat differently, energy differently. When you write del Q is equal to del U plus P del V, that is del W, there what is the meaning of del U? Del Q first, heat energy supplied. What is del U? Internal energy. And what is WW? Work done. So, work, heat and energy, they are not taken as same, they are treated differently in thermodynamics. Logically all three are same, Abhinand, as you are thinking. They are having same units, joules. That's why we are making an equation based upon that. As per the dimensions, we cannot make an equation if they are having different units. It should have same units. But we are treating them differently. You will understand slowly how, why, okay. So, let us first talk about temperature. So, temperature is the measurement of average kinetic energy of system. Remember that. The exact meaning of temperature means what is the average kinetic energy of the particle in a system. So, obviously it is in Kelvin. So, I have talked about hotness or coldness to you in the previous chapter itself, that is thermal properties of matter. I told you what is the meaning of heat, what is the meaning of cold. So, hot and cold are different from heat. So, heat can even be cold, isn't it? That means that heat is just the flow, that is where it is moving from hot body to cold to hot body. It can be anything. But remember that temperature is the measure of average kinetic energy of a system. Okay. So, next let us talk about the walls. That is, there are two kinds of walls we are going to study in this chapter. One is called as adiabatic wall, another is called as diathermic or isothermal, both are same only. What is the meaning of adiabatic wall? Adiabatic means insulating, which will not allow the exchange of heat between system and surrounding is known as, or between one system to another system is known as adiabatic wall. So, adiabatic wall is that wall which is having insulating nature. It will not allow the exchange of gas between two systems or system and surrounding. So, for example, if you are having adiabatic wall, then you can see that the temperature will not be allowed to pass through it, because adiabatic will not allow the exchange of heat between one body and another body, system and surrounding also you can say, or if there are two gases, then between two gases. That is called as adiabatic. Another wall is called diathermic wall. Diathermic means it will allow the exchange of heat between two systems or system and surrounding, and obviously it will have some, like you can imagine, like some pores between them. Whatever heat you are supplying, it will pass through it. This kind of wall is called as diathermic wall. So, adiabatic means it will not allow the interaction of the system and the surrounding. It will allow the exchange of heat between system and surrounding. This is called a diathermic wall. Are you clear on this? Diathermic means system will allow, that is the exchange of heat is allowed, and adiabatic means exchange of heat is not allowed. I hope basically you are understanding. Okay. Now, there are two words here, thermal equilibrium and thermodynamic equilibrium. How are they different? Equilibrium means something should become same, balance. Thermal equilibrium is temperature of two gases becoming same. If two gases attain the same temperature, then they are said to be in thermal equilibrium. Thermodynamic equilibrium means not only temperature, other thermodynamic variables like pressure, volume also become same. That kind of equilibrium is called as thermodynamic equilibrium. Are you getting my point? If two gases are having same temperature, they are said to be in thermal equilibrium. If two gases are in same temperature but different pressure, different volume, then they may not be in thermal equilibrium. They may be in thermodynamic equilibrium if their pressure, volume, temperature, everything becomes same. Only temperature becoming same, they cannot be said to be in thermodynamic equilibrium. They can be in thermal equilibrium. That is, thermodynamic equilibrium is thermal equilibrium plus physical equilibrium plus chemical equilibrium. All the equilibrium together is called as thermodynamic equilibrium. But thermal equilibrium means only about temperature. Is it clear to you? Thermal means only temperature. Thermodynamic means all the thermodynamic variables must be same. Okay, coming back. So, when see how they are defined, two physical systems are in thermal equilibrium if there is no net flow of thermal energy between them when they are connected by a path permeable to heat. That is, if you are connecting two systems by using a diathermic wall, but there is no exchange of heat is taking place because already they are in same temperature. That kind of equilibrium is called as thermal equilibrium. That is, they are in same temperature. So, A and B are there. You are connecting them by using a conducting wall. What will happen? Heat will go from which body to which body? Hot body to cold body. And within few seconds, what will happen? they will attain a equilibrium. That equilibrium will be called as what? It will be called as thermal equilibrium. So, here as they say, initially Ta may be more than Tb, but slowly Ta will become equal to Tb, and then they have achieved thermal equilibrium. If thermal equilibrium is achieved, no heat transfer will take place after that, isn't it? So, I hope you are clear with the meaning of the word thermal equilibrium. I hope you are clear, isn't it? Let us talk about this now. A very simple question, anybody can answer. If you use adiabatic wall in place of diathermic wall, is it possible to achieve thermal equilibrium?
No, sir.
Obviously no. Simple.
No, sir.
Very simple question. Obviously no. Why no? Because no transfer of heat is allowed between two systems if the wall is adiabatic. Very simple. Right. Now let us talk about zeroth law of thermodynamics. If you ask me why zeroth law, why not first law? Every other law, Kepler's law or Newton's law, we studied first, second, third, like that only we studied, no? But why here we are studying zeroth, first and second? We can have studied first, second and third. Any idea? We could have studied like first law of thermodynamics, second law of thermodynamics, third law of thermodynamics. Why are you studying 0, 1 and 2? Any idea? So, no. Anybody knows the history behind it? Why are we not calling the laws as first, second, third? There are 3 laws totally in thermodynamics. We are calling them as 0th, first and second. Why can't we change to first, second and third?
Sir, it might be like when they found the first law, after that they would have found this law, but this law might be like they thought that if we would have found this before, then like something like that. Sir.
Yes, good, you are correct, you are absolutely correct. The 0th law was found after the first law and it was more basic than first law. So, they put it before first, so they have no option, they have to put 0 only. Are you getting my point? Since 0th law was found after first law and naming that law as second law or third law was very irrelevant. The world will say later that what is this? Already studying the conclusion of 0th law is only there in first law. So, that is why they told that let us name this law as 0th law because it is more basic than the first law of thermodynamics, very basic law. What this law says, see, to understand this law, let us do a small experiment. We take on system A, another system B having different temperatures and they are connected with C. There are 3 different, A, B and C are at different temperatures. Now, what we are doing? We are making a diathermic wall between what and what? Between A and C and B and C. Okay, and we are keeping a adiabatic wall between A and B. So, there is no exchange of heat allowed between A and B, but exchange of heat is allowed between whom? Between A and C and B and C. Is it clear to you? I hope it is clear to you. Now, what happened? They left for some time. After some time, don't you think that A and C will attain thermal equilibrium? Same way B and C will attain thermal equilibrium. I hope you are understanding this very basic thing. So, after some time what will happen? A and C will become equal and same will happen with B and C also. Then they removed the wall and now they made adiabatic wall where? Here, where there was diathermic initially, and now they are keeping a diathermic wall. Do you think that now any exchange of heat will take place between A and B?
No,
Yes.
sir.
How weird? No, impossible. Already they have,
No.
yeah, no only, because all of them have come to same temperature. A becomes equal to C, B becomes equal to C, A will automatically become equal to B. If A and B have become equal, then where is the question of heat exchange between A and B? So, when we kept diathermic wall here and when we checked whether there is any exchange of heat there happening or not, no heat is exchanged. It means that now this all this experiment that I have done now, they are writing in a statement. What a statement can be? If system A and system B are in thermal equilibrium with system C, then system A and system B are also in thermal equilibrium with each other. Simple, right? If A and B are in thermal, not thermodynamic, thermal equilibrium with C, then A and B are also in thermal equilibrium with each other. I hope you are getting my point. isn't it? Fine. Anyhow, so same thing I have told, it is mentioned here that if two thermodynamic systems are in thermal equilibrium with the third one, then they are also in thermal equilibrium with each other. That is zeroth law of thermodynamics for you. Okay, simple, you can write it later. Now let us come to, okay, let me come to this now. First law of thermodynamics and the thermodynamic processes. So first law is actually more linked with thermal properties of matter chapter. If you are not good in that, you will struggle here. That is when I taught you del Q is equal to mc delta T, I taught you del Q is equal to ml, that part will be used here. So caution, if you are not good in thermal equilibrium, today itself go and become good in thermal equilibrium. You have the notes, you have the videos, you can see the video, take the notes also. I have taught in detail about what is the meaning of thermal equilibrium and what is the meaning of actually this del Q is equal to, that is change of state without changing temperature, change of temperature without changing state. You remember or not? Q is equal to mc delta T. I hope you are remembering here. Q is equal to ml.
Yes, sir. Calorimetry, yes, sir.
Calorimetry, yes, very good. So calorimetry, if you are good in calorimetry, then this is nothing. Just continuation of that. If you are not knowing calorimetry, then you have to know calorimetry before starting first law of thermodynamics. Okay, coming to first law, what it says. So now, before I start talking about the first law, you must understand the meaning of the internal energy, right? So when I say the word internal energy, when there is a gas in a system, if I have a system and there is some gas inside that, when I am saying gas is there, it means what is there? Gas molecules are there. And these molecules, do you think they are at rest? No, they are in random motion, here and there moving. If they are in motion, it's very certain that they will possess some kinetic energy. Don't you agree? So when the particles are moving left, right, here, there, they are having some velocity. If they are having some velocity, they must have some kinetic energy. Do you agree with me? I hope you are agreeing with me. Second is, their positions or their configuration will lead to potential energy of them. Because what is the meaning of potential energy? Energy possessed by a particle by the virtue of its position or configuration is known as what? Is known as potential energy of the system. So this internal energy is basically the sum of what? Sum of both kinetic and potential energy. Now once again I am repeating, kinetic energy is coming because of the motion of the particles and potential energy is coming because of the virtue of its position or configuration, whatever you want to say. Because of its configuration it will have a, so suppose I am asking this question to you, it is important thing, please pay attention. If I am having a system, okay, and I am having this piston which is immovable, I am not allowing the piston to move, and there is some gas inside this, and I heat the gas, what will change?
Kinetic energy, sir,
Kinetic energy will change.
of the particles.
Exactly. So that's why I say kinetic energy is the function of temperature. Remember this. Generally I am saying, please pay attention. Second thing, if I allow the motion of the piston, okay, the piston starts going above. If the volume has increased, don't you think the configuration would have changed? If the volume has increased or decreased, the configuration of the gas molecules will change. Do you agree or not? Can I say that potential energy is the function of volume? This may come in the examination. Kinetic energy is the function of dash. It is a function of temperature. Potential energy is a function of dash. It is a function of volume of the gas. I hope you are getting what is the meaning of volume and what is the meaning of temperature and how it is related. Anybody has doubt in this? I hope no. Very basic thing we are learning. Pratap, please check your mic. I think it was on. Yeah, fine, now it's okay. Yes. So next, again, internal energy is a state function. That is, it does not depend upon the path followed by the process. So I told you energy is state function. In the beginning itself I told you. Energy is state function. What is the path function? Work done and heat. Good. So now it means whether a particular system is moving from 1 to 2 in path A, path B or path C, what will remain same? Its internal energy is a state function, so it will not depend upon which path a system is following. That's why I told you, you should remember that state function is what and which of the parameters are state function. Energy is state function, right? So UA is equal to UB is equal to UC. That's what it is mentioned. Fine. So now let us talk about one simple question. What is the change in internal energy of a process which has final and initial states are exactly same? What will happen? Options I will give
So,
you.
pardon getting up. Adi, sir.
What is the change in internal energy of a process which has final and initial states exactly similar?
Zero.
Common
Zero,
sense,
sir.
0.
Zero, sir.
This kind of questions, if it comes, you should dance. It will never come. Okay, obviously it will be 0. Fine. Yes. Now let us talk about heat. Because see, if you remember, most of you may know by now that first law of thermodynamics is Q, work done, and U. So I am going to talk about each thing one by one, and I will assemble all three and make the equation. So first I talked about internal energy. Now I am talking about heat. So heat is the energy in transfer to or from a thermodynamic system by mechanisms other than thermodynamic work or transfer of matter. So suppose I am putting a burner below a system. What I am supplying? I am supplying some heat. So what they are saying, it is energy in transfer to, like if I am heating by using a burner, or from, it means the system is heating the surrounding. That is from the system it is coming. A thermodynamic system by mechanisms other than thermodynamic work. That is, you should not move the piston. Are you getting my point? That is work done. It cannot be coming under the condition of heat. That may also produce heat, right? If you have a piston, suddenly you are moving it. It will produce some heat, but that is not this heat that I am talking about. This heat is externally supplied or removed from the system because of its interaction with the surrounding. So be clear in the meaning of heat. This heat is not produced by any thermodynamic work. I hope you are understanding something. So suppose there is a high temperature, obviously the heat flows from where to where? From high to low temperature, always remember that. So heat always flows from high to low. Right. Now sign convention. Sign convention is also very important in this. Positive, negative, you should know, because when you solve a numerical, it will be used. So if heat is applied, it is positive. If heat is given away, it is negative. Common sense. If heat is coming inside a system, it will be taken as positive heat. If heat is given away by a system, it is taken as negative. Yes. Tell me, ma'am. Yes. So I hope you are clear in the meaning of sign convention of heat supplied or heat rejected. So once again, as I told you, heat is a path function. If it is a path function, it depends upon which path it is taking. Fine. So types of heat, once again, this comes from thermal properties of matter. I said you that if there is a change in temperature, what is this? Change in temperature is what? Q is equal to mc delta T. You have the mass. If you have the delta T value, you can find the heat supplied for that, isn't it? And if it is changing its state at a constant temperature, what is this called as? Latent heat. Remember this? In this case, latent of fusion. So they are calling it as latent heat. Same way, once again, the water is going from 0 degree water to 100 degree water. What is happening? Sensible heat, they will write.
Heat in temperature.
Yes, sensible heat. And when it is going from 100 degree water to 100 degree steam, what is going to happen? Latent heat of what? Vaporization. This thing is,
Vaporization.
yes. If you are clear in calorimetry, this is child's play for you, isn't it? This we have learned very detailed. in the thermal properties of matter. I hope you remember this. Fine. So it is a form of heat which is responsible for change in temperature of system, and latent it is the heat responsible for change in phase. I hope you know this. This heat is change of temperature, this heat is change of state. Same way, change of temperature and change of state. In detail you have studied, please go through the video if you want to go. Okay. Then comes the work. We talked about heat, that is heat, we talked about internal energy. Let us talk about thermodynamic work, because we are going to link all these three only. So, again, work performed by a system is the energy transferred by the system to its surrounding, or it can be vice versa also. It can be heat supplied by the surrounding to the system, isn't it? So, for example, if you see there is some water may be boiling here, or some kind of process, heat is produced, and by this production of heat I am doing some work, isn't it? The work is done if you are supplying some energy to the system, I mean by a surrounding, or transferred by a system to the surrounding, or surrounding by a system, any way it can be. So, work is a form of energy, but it is energy in transit. Mr. Abhinand, understand this. Work is a form of energy, but it is not that energy that we are supplying, it is the energy in transit which is keep on moving, it is doing some work, isn't it? Can you see from here? So, yes, so that is thermodynamic work, okay. So, now if you see a closed system, I mean let us talk about this when we come to equilibrium concept. First, again sign convention says that if work is done on a system, then it is negative. When work is done by system, it is taken as positive. See, these conventions will help you in solving numericals. Numerical will come where by using your logic you take plus or minus sign. So, if heat is done, what you are thinking, opposite in chemistry, then
Work is done on the system, it is positive. Work done by the system is negative. Then the same will apply to this also.
Tell me again, what
Work done on the system we call positive.
who told like that? In chemistry studied, no? Again I am repeating, the conventions that we use here and there may not be same. It is not like same conventions they are using. One thing I will tell you, overall if you see, no, the convention of physics that we are going to use will be exactly opposite of convention that we are going to use in chemistry. Convention is what here? Convention is if you take one thing as positive, the thing will be negative, right? Like if you remember about optics, you have studied that all the distances measured along the direction of incident ray is taken as positive, and all the distances measured against incident ray is taken as negative. I hope you remember this from 10th standard. If somebody is taking all distance along the incident ray as positive and opposite to incident ray is negative, he will not be wrong. Convention is something which is human made, not God made. So, what it is done? It is taking one thing as positive, opposite will become negative. Same way here, if I am taking the heat done, work done on system as negative, then work done by system will become positive. But what you should remember is convention, if you are taking in one way, you should take always in the same way. So, if you see NCERT book also, the same thing will be written about convention. It is little different from the chemistry's thing. Okay. So, if you see, yes, heat and work both are energy in transit, which is different from what? Heat, work, and what is the third thing? Energy. So, energy is different from heat and work done, because heat and work done are energy in transit, but energy is something which is supplied externally. Again, it will be confusing, I said to you, energy, heat and work all are same. But if I write del Q is equal to del U plus del W, del Q is the external heat supplied, del U is change in internal energy, and del W is the work done by the system on the surrounding or work done on the system by the surrounding. Both is possible, right? So, energy that is del U and del W, they are path functions. And del Q is the energy supplied, it is state function. These kind of questions are coming directly in the examination, even in the competitive examination. So remember that. Maybe slowly when you go with some numericals, you will be able to understand it better. So what is the first law of thermodynamics? Very simple way here. If I am having a, like if I am doing like this, if I am making a system and I am having a system, piston, and I am supplying some energy to the system, what will happen? Whatever heat I am supplying, that heat will be called as del Q. If the piston is allowed to move, then what will happen? It will go to a new position like this, isn't it? If it is moving up, there is some work done, and since heat is supplied, there is some change in internal energy. So whatever heat you are supplying is getting utilized in two ways. One way is to change the internal energy, second way is to do some work. Work done by whom? System on the surrounding, or it can be vice versa also. I hope you are getting my point. This is very, very, very important core of this chapter. This chapter, zeroth law is child's play, second law is again theories are there. The whole chapter is basically first law only, remember that. Today if you are failed to understanding, next class will become horrible for you, because there I am going to talk only about first law, numericals based upon that, processes, everything, isobaric, isochoric, everywhere what I will do. I will tell what is the meaning of isobaric process, and then I will tell you isobaric process, what is the work done, and what is the first law applied on isobaric process. Same way isochoric process theoretically, and isochoric process I will tell what is the work done in isochoric process and what is the first law of thermodynamics applied in isochoric process. So first law of thermodynamics is the base of this chapter, it is the backbone of this chapter. Don't fail to understand this. Okay. So the same thing they would have written in the form of equation, where they will write del Q is equal to del U plus del W. That is first law of thermodynamics. Again in chemistry, study in a different way, negative use. What you study? Del U is equal to del Q minus del W. How you study? In chemistry, how you study here? Same you study. For you? Same only. Okay. Because some people have told some minus sign comes. Maybe they are writing del U is equal to del Q minus del W. I don't know how. Maybe that depends. Okay. Anyhow, but this is clear to you? I hope you are understanding what is happening here. Okay. So let us go to one question if it is possible. Yes. Can you solve this question, everybody? Take 2 minutes of time. To get some confidence, you just solve this question. A gas is compressed in a cylinder by a movable piston to the volume half of its original volume. 300 kilojoule of heat leaves the gas and internal energy remains the same. Find out the amount of work transfer. So make it fast.
Sir, I just have a doubt.
Please ask me.
Sir, the formula is del Q is equal to del U by del W, sir.
Yes.
They said del U is constant, so there's no del U. U
U?
is constant, so there's no del U, right?
U is constant, how do you say?
They're saying internal
Okay,
energy
okay,
remains the same.
Huh, fine then.
So del Q is equal to del W, right? That's all.
Okay. The answer is how much? 300 kilojoule?
Yeah, 300 kilojoules.
Do you agree with him? Everybody else? Try. He has given his own answer. It may be right, it may be wrong. Give your own try.
Sir, is it 300 kilojoules?
Same thing what he said. Pratap?
Yes.
Okay. Others,
So even thing is same, sir. U2 minus U1 is actually.
exactly. But see, why it is minus 300? You are understanding?
Because it's compression.
It's giving, oh, okay. It's half.
Here,
It's half.
negative, positive may plays a role. They'll get half marks for this minus sign. Your answer is right, Abhinand. But don't put this negative sign. It depends upon the teacher who is correcting the paper. He may cut full marks also. Or if some teacher who is having some mercy on you, they may take half marks from you. Okay. So, I think today many children are busy in celebrating New Year. Already they are in, I don't know what mode, many are absent. And those who are there also, they are waiting for me to go, and I will go and start, I don't know what they will do. I don't understand really. New Year means you will do some party, or you will go, you are that, which age group you belong to, you have to sleep only by 10 o'clock. But still you have a lot of plans for this New Year. Okay, anyhow, celebrate, enjoy. I am going to end soon now, because we are going to continue this class in the next session, and many of them are absent. I don't want them to miss entirely. They will not see the video also. So why to waste their time? Once again, they will ask me to reteach. So for that, let us continue next class. Next class, now what is remaining is numericals based upon first law of thermodynamics and thermodynamics processes. That is the main part. And then second law and statement. Very simple things are remaining. We will do that in the next class. So till then, take care. Bye-bye. Again, I am repeating, notes, please take it from the video link I am going to share now. See once again, revise once again, and while revising, take all the notes. Today I not allow you to take the notes because I went little fast. You are copying, it is taking time. So I went to complete more portions with you to take the notes later. But don't forget, take the notes. If you don't take, you will miss it. Believe me, you will forget tomorrow. So today itself, or maximum by tomorrow, take all the notes. Shivaranjani, don't forget that. Now itself you took, huh?
Yes, sir.
Okay, anyhow, please have the notes proper in your hand, okay? Take care, bye-bye, good night. All of you can drop off.